Hello, here we'll go over examen VWO 2021 Tijdvak 2, period 2. Question 1. Een kromme, a curve k is given here with some parametric equation with t between 0 and 1/2 pi. There's also shown a raakline, which is a tangential, and they say that the slope in a certain point x, y can be calculated with this equation. We have to prove that. Okay, so with these parametric equations we can, you could try to express y into x, but that's generally not so straightforward. But what we can do, and I assume that is basic material for VWO 6, we can see that basically dy dx is basically dy dt divided by dx dt. This is probably not a really precise equation, but I think this is something that readers can use. And now we just have to calculate the derivatives of each. For derivative of the sine cubed, we just use the chain rule for calculating the derivatives. You see that all over again, so you have to know that. What you get is 3 and times the cosine squared of t, and then times the derivative of the cosine, which is actually a negative sign, and that's just easy to remember because the cosine goes down, decreases around 0, so that's how I remember this minus sign here, and we divide it by we do the cosine cube derivative similarly. You get 3 times sine squared t, and then times the derivative of the cosine, okay, good start. I did it completely. I messed them up. Oops. Yeah, guys, check step by step. For the chain rule here, you first take the derivative of the power here, so we get sine squared t, and then the derivative of the sine, which is the cosine of t. Well, it's a warm-up exercise, so don't worry. And here we get the cosine squared t and the minus sign of t. And then a lot of stuff will drop. This will drop. I get a 1 here. These will drop. The 3's will drop. And I end up with sine t divided by cosine t. Question 2. They give this equation of the tangential in a certain point, and prove that this is correct. Okay, well, we know the derivative here, so we know the slope. And now we just have to prove that this point is on the curve. So we have to prove that if I substitute this y and this x, then they should be equal. I have to basically have to prove that this point xt yt is on the line. So I get sine. I have to show that sine cube t is equal to that thing with x is cosine cube plus sine t. So sine, the cosines will drop here. Cosine square t and you kind of can see what will happen. You have this is sine times the sine squared, and here as well. So that is easy, nicely to combine. Let's move them all to the left side, actually, and factorize the sine. Let's do that in one step. Bring this to the left, got a plus and a cosine squared t and a minus sine t here. This has to be equal to 0. Well, this is 1, so basically get sine t minus sine t, which is 0. So this point is on this line, so indeed it's tangential. 3. This tangential crosses x-axis in A and the y-axis in B. Prove that the length of AB is constant, meaning that it will not depend on t. Okay, well, let's calculate A and B. B is, of course, that happens when x is 0. It's basically the intercept. This is the slope-intercept form, so actually you can, it's kind of trivial that B is, the x is 0, and the y is sine of t. Well, A, for A, we have to set y is 0 and find for which x that happens. So let's find out. this has to be zero. Bring, say if you want to isolate x, bring x to the left. And then you can also factorize sine t, so also let it do it in one step. Okay. Sine t, I brought this to the left and factorize sine t, so I get x divided by cosine t. And here I get a minus sine of t, but I factorize sine, so I get just a minus 1. So for this to be 0, that means that x is cosine of t. Also, also the sine of t can be 0, which happens that t equals to 0. Let me see if that's a special case that we have to include. Let's look at it. So we get first, if the sine of t is not equal to 0, we get for the length of this AB is okay, let me first try. So A is cosine t 0, and the length is then or the length square is the x coordinate of A, which is cosine t, minus the x coordinate of B squared. So it's cosine squared t plus the y coordinate of A, 0, minus the y coordinate of B, which is sine t. But it's squared, so you get a plus sine. Or you get a square of a minus sine t, which is the same as the sine squared of t, which is 1. So it doesn't depend on t. So what happens if sine of t is 0? Well, then our y is 0, of course. And then our x is, and that means that t is equal to 0 in this interval, which means that x is equal to 1. So that means that point B is actually in that case the origin, 0, 0, and A is 1, 0, and that also has the length of 1. So it actually is completely independent of t. I'm not sure if points are withdrawn if you don't point that out, the situation that sine of t is 0. Otherwise I would still write it down. Moving on to 4, reflection of vectors. If you have a vector that's reflected in a line, you have to reflect the starting point and the end point of the vector. And then the reflected vector is basically a vector constructed from these two. And they give here a vector AB, and if the image of that, the mirror image in this line is given by CD. And now they give a point 7,2. And this vector OF is reflected in the x-axis, and the reflective vector is OG. And for a certain combination of P and Q, we have POF plus QOG is 7 minus 3. Well, so now actually so this was just an example. They actually look at reflection x-axis. Well, so let's say I have my F here. Reflection in x-axis just means flipping the sign of the y-coordinate of F. I think that should be something that you can just state. So G is simply 7 minus 2. Which means that this combination here is just P times 7, 2 plus Q times 7 minus 2 is 7 minus 3. Which means that 7P plus 7Q is 7, 2P minus 3Q is negative 3. This you can just simplify a little bit by dividing by 7. Okay, two equations with two unknowns. That should be pretty standard, but it's actually still easy to make mistakes. I guess the standard way is just eliminating, say, the first variable first, P. And I do that by multiplying the first by 2 and then subtract the 2. And there are many ways to do that. That all should give the same answer. Minus 3Q, I keep this. And subtract the 2. Subtract. And then I get minus 5. You see, I only make a mistake. 2Q. Well, let me just take a bit more space. Subtract the 2. These drop, so I get 5Q. How come there's a... Alright, so see how important it is to check step by step. This is a minus Q. 7, 7, 7, 2P minus 2Q minus 3. Always a good idea to double check every step instead of rushing too much and ending up with very ugly numbers, for example, which in the end you waste more time on. So I get 2Q minus negative 2Q is 4Q is 5. So q is 5 over 4. And now I just substitute in either of them to find p. So p, I just use this one. There's a lot of lag in my pad, unfortunately. So my arrow is misplaced. I had 1, then bring q to the right hand side, minus q is 1 minus 5 over 4. I write it in equal denominators, 4 over 4, so I get p is minus 1 over 4. And that's the answer. Question 5. We have a line k with this vector representation, and the factor OF is a reflection in line k, and find out if the reflection of OF in this line is to the left or the right of the y-axis. So it's something like this. We have a line k, oops, has to go to the origin, and a point F here. There's such a lag in my pad that it comes out very ugly. Well, how to construct the reflection? We have to need to construct a line perpendicular to k, and then the reflection, let's call this G again, is like of equal distance away from k. And well, how can we find this? We have to construct the line perpendicular to k going through F, and then find a point in between. Let's call that H. That's the intersection. And then this point has to be right in the middle, so it's like H is 1/2 F plus G, or G, so G is the factor we want to find. Multiply this by 2, bring F to the left, so it's 2H minus F. So if we look at G and find that the x coordinate of G is negative, then we know it's to the left, and otherwise it's to the right. Okay, so let's then find out point H, we know point F, then we find G, then we have our answer. So what is the line perpendicular to K? Well, you can again write the general form of that perpendicular line, let's call it L, by writing the slope-intercept form, and then find out what the slope is of K, and demand that the product of these slopes is -1. But another way is, and I suppose that is again standard knowledge here, it's the direction factor 3 over 4. You can easily find a perpendicular direction factor by using that the cosine between, or the cosine of the angle between two factors is AB divided by the norms of these. And a perpendicular means the cosine is 90. Means the angle is 90, so the cosine is 0. So I just have to find a factor that's when doing the inner product with this, the inner product of this is 0. So Well, that's actually very easy to find. You just flip the two and have one negative sign. So you can see that the factor minus 4, 3 is perpendicular to this direction. Okay, so I would suppose that this is stuff that is part of the skills you need to know. Okay. Okay, now we have to demand this line, this perpendicular line has to go through F. So I know the direction factor, and I know F has to be on this line, so my line L is just 7, 2 plus lambda is minus 3. So this is the factor representation of L again. And now I have to intersect it with K. So I want to find H. So what I do is just say that this thing here has to be equal to T times 3, 4. So I get 7 minus 4 lambda is 3t. 2 plus 3 lambda is 4t. And I can say eliminate lambda and substitute t to find what h is. So what I do about this times 3, this times 4, and oh, maybe you should just write it out. But you can do it in once as well. So this is 21, get 21 plus 8 is 29. Minus 12 plus 12 is 0, that's what we want. And I get 90 plus 16t is 25t. T is 29. Okay, so did I do it correct? 2 plus 3, 4. I'm always a little bit suspicious if you carry these ugly fractions here, but I guess it's correct. So h is then 29 divided by 25. Gee. This is the factor 3, 4. I don't know why I wrote 3 over 4. 3, 4. Well, I don't know a simpler way to do this. 3 times 29 is 60. Plus 3 times 9 is 27. Is 87 divided by 25. And 4 is 80 plus 4 times 9 is 36. It's 116. divided by 25. Okay, so if all is well, this is h. Well, actually, we just need to calculate the x-coordinate of g. So gx is just 2hx minus fx, or okay, the grind is real. Let me the x coordinate of g is 2 times the x coordinate of h minus the x coordinate of f. So that is 2 times 87 divided by 25. Minus 7. 160 plus 14 is 174 divided by 25. I want to put it on this equal denominator. Well, actually, I only have to see if it's negative or not. So, I don't need to do much more. But it's 7 times 25 is 175. Ah, what a miracle. So this is actually minus 1 over 25. So so perhaps it's still correct, because the turn out to be these numbers are probably not a coincidence. Well, you're never sure. But if I'm minus 1 over 25, which is actually to the left, so the answer is to the left. Well, a lot of work, guys. Raaklijnen bij een vierde graads functie. Raaklijnen are tangents again. This function is given here with a parameter p. There's a line k with the equation y equals px. It's given here. This line k has a tangent in the origin for every value of p, actually. Okay. Well, if I take the derivative in 0 of this function, that should be p. So yeah, that makes sense that this is a tangential going through the origin. There's a line L which is tangential in a point A with x coordinate of 2. And this line L intersects the y-axis in a point B with y coordinate 4. The intersection of K and L is M. and prove that M is in the middle of A and B. So first, what are they asking us to prove? They asking to prove that M is in the middle of A and B. Or in other words, it's in the middle of, you can see this for both the x and y coordinate. So we just need to, well, see what we know. Let's first calculate L, and that's so we can find the slope of this line. Although you can find the slope from this line from the derivative of the function at x equal to 2. On the other hand, you can also find the slope from just knowing that A and B are on it. But let's just calculate L just based on what we know, that it's a tangential at point A. That should be sufficient. And point B just has to lie on this line. So what what is A? It's 2, and then a function at 2. So that is 16 divided by 4 is 4, minus 2 to the power 3 is 8, is minus 4, plus 2 times p. That's minus 4 plus 2p. Oh. It's 2 minus 4 plus 2p. The slope of the tangential, so I find derivative at 2, and it's, well, let me still write it out. We use the known derivatives here, but at x equals 2, 2. So it's 8 minus 3 times 2 to the power 2 is minus 4 plus 2p. And this point has to be on the line, so let me say first, we assume it is of this form, but we know the slope here, minus 4 plus 2p. We demand A is on the line, so the y coordinate of A has to be equal to minus 4 plus 2p times 2 plus b. So b equals, I bring this to the left, it's a minus 4 here, 2 times minus 4 is minus 8, it becomes a 4, and bring the 2p also to the left. Let's see, I will check. A is 2, f of 2. To P. Ah, this is a mistake. And I didn't listen to myself and check every step. So the slope is minus 4 plus P. And actually the reason that I know that this I made some mistake is I don't want B to depend on P, because I already know that B is given by 0, 4, which doesn't depend on P. So now what happens, I bring the terms of P to the left, then the axis drops, so you get just B is equal to 4. So L is given by this expression. And I know, and then you can check that indeed if you substitute 0, you get y equals to 4, so B is also on this line. Okay, so I found line L. I know what B is, I know what A is. So I can find M by saying that it is also on line K, and line K is already given. Line K is y equals to px. So I want to solve these for every p. You get two equations with two unknowns, y and x. The simple way here is just to substitute this equation in the first. So I get px is equal to that whole thing here. Sorry. Because that early mistake, I repeated that mistake. The slope was 1, or the slope was minus 4 plus p. So that's, again, because the line L is given by this expression with the slope minus 4 plus p. And I substituted point A in it, found that B is 4, and I found that B is also on the line, and I'm intersecting it with line K. And I get this, and now you can see that if I bring px to the left, I just get 0 equals minus 4x plus 4, which means that x is equal to 1, which means that the x coordinate of m is 1, and then the y coordinate is p, so m is given by 1 and p. And then I have to show that it's also equal to 1/2 a plus b. Well, what's 1/2 a plus b? Let me see. The x coordinate of this is 2 plus the x coordinate of b, which is x coordinate of b is 0, so I get 1. Let me just write it out. It's 1/2 2 plus 0. For the y coordinate, I get 1/2 times, and now the y coordinate of a, which is minus 4 plus 2p plus the y coordinate of b, which is 4, and this is equal to 1 minus 4 plus 4 is 0. This is 2p times 1/2, 1p. So yes, we've shown that this is actually 1/2 a plus b, which prove what they wanted to prove. Moving on to question 7. We have this line k, that's the same line here, and this line and the function enclose a certain area phi, which is drawn here in gray. And what is the area of phi? Well, that's the integral from, well, this intersection here, assuming that it doesn't intersect more, which is not likely, we will find out, and the x coordinate of the intersection here, let's call that b, of the line k, which is given by y is px, so px minus fp of x dx. This is what they're asking. So let's find this a and b. Well, we need to intersect, so we want to set this function equal to the expression of the line, which is also px, which is nice since they drop out. So actually a and b don't depend on p. It is interesting. We get then these terms have the common factor x to the power 3, so we get 1 over 4x minus 1 is 0, so x is 0, or x is equal to 4. So a is 0 and b is 4, and there are no other intersections here. Okay, so let's substitute the function here. I get this from 0 to 4, and px minus this function, so you get minus 1/4 x to the power 4, and then negative minus a negative time negative x to the power 3. That's then a plus. Dx, and that is not too difficult to get the primitives from. just a little bit careful here with the factor you get from the exponent. I get a 1 over 5 if I do the derivative, so I get a 5 if I do the derivative, so I need to compensate by having a 1 over 5 times minus 1 over 4, so I get a minus 1 over 20. And here the same, I'll get some power 4, and I need to compensate for that by having 1 over 4, so I get this coefficient 1 here. And this is between 4 and 0. So 4 to the power 5. Ah, 4. Well, if I write it 2 to the power 10, you can just use your calculator as well. But I happen to know that 2 to the power 10, because it occurs often in binary systems, is 1024. So you can actually also, well, yeah, simplify that a little bit with the 20 here. And x 4 to the power 4 is 2 to the power 8, it's 256. So this is 2 to the power 2 times 5, so it's easy to simplify this. This is minus 256 then, divided by 5. I just simplify each fraction here, and 4 to the power 8, so this is 64. Interesting. Well, we still have to put it in the same denominator. And 5 times 64 is 320. So I get 320 divided by 5. Ah, my God, that. Actually, I would just use the calculator in these things, just to prevent any mistake, or at least double check your answer. This is 64 divided by 5. I think probably giving this answer in this form should be okay. Yeah, let's just. You cannot simplify it anymore, actually. So that should be it. Bank equations. we have a saving account and a certain amount is deposited. The yearly interest rate is constant, and then the balance will grow exponentially, and the account owner would like to know after how many years the amount will double. And is using this equation with t the time in years for it to double, and p the interest rate. They say percentage, so it has to be expressed as a percentage. So proof that this is correct. All right. Well, let's start. Say I deposit a balance of B0, and then I know that over time what's on the account is B0 times 1 plus the interest rate. But just following this form here, if you put the interest rate P in the percentage, is P divided by 100, and then to the power T, which should be the time in years. Now, for this to be double, it would just mean that this is B as a function of T, has to be twice what was there. Oops. So that's that expression here. So what does it mean? It means, well, let me still write it out, doesn't hurt. So the question is when? When does this happen? 1 plus P divided by 100 to the power T. When does this happen? And fortunately this drops. It actually doesn't matter how much you deposit initially, obviously. So how do I solve that? Well, I take the logarithm on both sides. Actually, you could use any logarithm of any base, but they want to use e as a base here. And let me bring this. Doesn't matter. Okay, so I get log 2 is log of that thing there. And the nice thing about this is that I can use the known properties of the log to get this t in front. And let me already flip left and right as well, so I get t log 1 plus p divided by 100 equals, what's that, log 2. Okay, so I get log 2 divided by that whole thing again. Okay, not too difficult, but apparently this kind of compound interest equation has to be known by the student. It's not given here. I will check that again in all the exam requirements. I will make a video about that later as well. And let me see if I have enough space for 9. They say that that this is not an easy equation. So in the banking world they use a approximation which they call bank equations. And apparently that's they look at this function n given here and they draw it in the figure here. We have n, and they also draw the tangent k in the origin, and this is they already give you what it is, so that's good. Then they say if x increases, then the vertical distance between these two will get bigger and bigger. And prove with help of differentiation that this vertical distance becomes bigger and bigger. Well, what is the difference between these? That is the, let's call it d, as function of x is 1 over 100 x. It's probably easy if I redefine x, this as a x over 100 as an x prime or something. But maybe it's not too difficult. And then minus the function n. And that this is increasing, that this is increasing, and I think it makes sense, because this kind of goes as a logarithm. But if we will calculate the slope, because that's what they're asking, calculate the slope of this difference and see what happens if x grows large. If that slope is always positive, it means that this difference function will rise, the difference will get bigger. So what is the prime of x? It is 100 times the derivative of minus the derivative of the logarithm, and that's 1 over x with the chain rule. So we get minus 1 over 1 plus x over 100 and times the chain rule. Remember the chain rule, guys? Times 1 over 100. It's 1 over 100 minus why do I always do that? Plus x. Well, yeah, if x becomes large, actually this thing this whole term actually goes to 0. So as x becomes really large, this is just 1 over 100. But in general, when x is larger than 0, this slope is always positive. It starts increasing here, and the difference will start increasing here and will continue to do so. So it's larger or equal to 0. So I think that proves it here. Alright, well, a lot of words. Not a big fan of this, but I've seen it a lot in the recent exams. My god. Okay, for small positive value of x, the exact equation and let's say the so-called bank equality are pretty close. And they say they call T1 is actually the estimated one. And they say for larger p, the approximation starts to differ more and more with the exact equation. That's why they change the numerator if p gets bigger and bigger. For example, to 72. And this is actually equation for when your balance doubles. So then you can compare this doubling time for different values of p with the exact equation. My god. And they put this in the table here for 1.5 or 5.5. This is the doubling time in years. So obviously if the interest rate is low, 1.5, it takes much longer than 5.5. Then you can see that and these are the approximations, and obviously for 1.5 the 70 over p is closer to the exact. But for 5.5 the 72 is closer to the exact formula. And calculate this. For a certain value of p, so for a certain value of p, one of these two is better. And then they calculate this. And in 1 decimal. So that generally already means that this is probably going to be done by the calculator. But okay, 10. Well, what is the difference here? It's just the difference between the exact and the formula. So what will be the transition? That will be actually when they both as the same, if they're both as good. So if the difference between the exact and the approximation is the same. So we said log 2 divided by log 1 plus p divided by 100. So this will be one approximation is equal to log 2, the whole thing again, minus 72 divided by p. And actually we don't care about the sign of the approximation, and so we have to also add the absolute values here. Oops. Actually you can see if you wouldn't have done that, these two drop, and that is actually there's no p for which they would be equal. So we get something of the form absolute value of a is equals value b, which means that either a is b or a is negative b. So with if you would look at a is b, so without to think away these absolute value lines, then you see that it won't have solutions. So we need to look at situation where one is the negative of the other. So that would mean that log, well, I have to do a lot of writing here. I guess it's still good to completely write it down, so if you make a calculation mistake, you get still some points. And apologies for the poor writing on the writing pad. So just bring this to the left, and I guess there's not much more useful you can do. Oh, of course, yeah, you can still subtract. Yeah, so what you get is 2 log 2 divided by log 1 plus p divided by 100 equals, and let's bring this to the right, and it's 70 plus 72 is 142 divided by p. Now, I think this is not done analytically anyway, so let's use the Wolfram alpha, since I don't have a graphic calculator. 2 times log 2 divided by log 1 plus p divided by 100 equal. So in your calculator you would write, I guess you just write two functions, y1 and y2 intersect, or I guess one function and ask when it's equal to 0. So 142 divided by p. Double check. And then I get p is roughly 4.9. One decimal, so years. Two graphs of square roots. We have a function f and g, and on f we have this point p. The slope of f and p is 1 over square root of p. So they already give that. And then a line from the origin to P intersects G in this point Q. And then they say the slope in this point Q is actually the same as the slope in P for every P. Okay, well, let's for every P we can just call this line LP or something. LP. And that line has to go through origin and P, so actually it means it's a direct, I call that direct relation, or anyway, the intercept with the y-axis is 0. So this line, a line going through origin and P, is just given by okay, let's just say its y is a times x, and since this point P has to lie on it, it means that this has to be true. In other words, A is 2 divided by the square root of P. So our line LP is simply y equals 2 divided by the square root of P x. Did I do that? Yeah. And they say if I intersect that with Q, at that point the slope is also 1 over the square root of P. Interesting. So let's do that intersection first. So I want to calculate point Q, so I need to set the y value of the line, the same as the y value of the function. So I get this equation. Let's multiply both sides by the square root of p and divide by the square root of x. So I just let's take the square both sides. Got 2x is 4p x squared. That is definitely true if this is true. Is that correct? Yeah. So 4p x squared minus 2x is 0. Factorize x or 2x. 2 over px minus 1 is 0. Therefore, x is p over 2. X is p over 2, and I just exclude x is 0 here. We might have to just check what happens there in a little bit more detail. So that is the x coordinate of q. So let's see what the derivative is of function g. Well, so g prime in p over 2. What do I have here? It's the derivative, use the chain rule, 1/2 and 2x to the power minus 1/2, but times the 2 again, picked up by the chain rule, the derivative of 2x. So it's 1 over 2x. But I want to evaluate it at x equals p over 2. So I get 1 over the square root of p. And that was given. This is given as the slope of f at point P. So that is what they were asking then. Question 12. P equals to 4 and there is a point R on G right beneath point P. So they have the same x coordinate 4, and then the tangent in P and R intersect each other in minus 4, 0. Does that make sense? Probably. So they already give it, so I think there's no need to check what is being told here. You can imagine that it will happen. Maybe if a lot of time, you can calculate it and double check that if p equals to 4, it indeed crosses here. But just for time's sake, let's just assume that this is true. And just calculate the two areas. So the area of the triangle, call it T, well, it's just half times the base times the altitude, the hoogte in Dutch, of this triangle. So it's 1/2. And what's the base? The base is the function in P, a function f in P. So that's 2 times then the square root of 4 minus the function g, which is the square root of 2 times 4. And so this is the base of the triangle. What did I say? Then times the altitude. And p is 4, and this distance is also 4. So I need to multiply by 8. So I'll get 4 times, this is also 4. And this is, I can pull the 4 out of the square root sign. So it's 2 square root of 2. Yeah, there's not much more you can do with this. You can still, they still have a common factor here, 2. So I can write it as 2 times 2 minus square root of 2. And what about this area here? They didn't give it a name. Let's just call it G from, that's a G from Cray. And that's the integral of this function from 0 to 4, I should say. And of 2 square root of x minus dx. But let's factorize the square root of x here. You don't need to do it, but I think it will simplify some stuff. So square root of x times 2 minus square root of 2. Actually, you can see already this kind of constant coming out. And I can actually pull this in front of the integral. So it becomes actually much simpler than I thought, if all is well. Okay. Well, this is this thing here, and the primitive of the square root of x is simply square root of 3 over 2. But need to have a compensation coefficient here to get the constant in front of here, 1. Again, double check it. as always, by doing the derivative. So I get between 4 and 0. And 4 to the power 3 over 2 there's 100 different ways to do this, but one way is, okay, this realize 3 over 2 is 1 plus 1 half. So we get 4 times 4 to the power 1 half. And this is 8. Alright, that is pretty good. So I get, if I do the 0, I don't get anything, so I get 8 times 2 over 3. So I get 16 over 3 times this term here. So what did they ask again? They asked AG divided by AT. So then the term to square root drops. It's 13 over 3 divided by 8. It's 2 over 3. There's this function given, shown here, and you have to show with an exact calculation the equation of the asymptotes. So the limits of x to x plus or minus infinity of f of x, as you can see from the graph, is actually e to the power 0 is 1. And since minus 1 over x goes to infinity if x approaches 0 from the lower side, then you'll find that the limit of x approaching 0 from below f of x is e to the power infinity. Infinity. So the asymptote is x equal to 0, and here the asymptote is y is equal to 1. And then the inverse, simply for the inverse, then you get it's flipping x and y, you get x equal to 1, or this becomes y is equal to 0. Then they talk about a derivative. Okay, they already give it for you, that is nice. And they say the domain is restricted to x greater than 0. There is a tangent, point P, intersects the x-axis in point S, and obviously the x-coordinate of S will depend on the position of point P. But they say there is a certain position P for which this x-coordinate is a maximum. Okay, well let's set up this line and cross it, intersect it with the x-axis. So the tangent through, say, point P, and well, whatever the function is at this point, is something we first calculate. So what's that? Well, f prime at P is 1 over P squared e to the power minus 1 divided by P, and it goes through this point. So let's set up an equation. Let's call this L and make it of general form ax plus b. And now we found our a, and we demand this point is on it, so we say that not this point, f is given here, so we need to have e to the power minus 1 over p has to be equal to this thing times x, not x, sorry, what did I say, times p, that's the x coordinate, plus the constant b here, so p equals, I bring this to the left and I factorize what I can. I factorize e, that is this term with e, so I get minus 1 over p times 1 minus 1 over p. The p divided by p squared is 1 over p. Okay, so now we can, now we have found this one here. Again, too much lag. And the x-coordinate here I just find by setting y is 0 in this function. So 0 equals 1 over p squared e to the power minus 1 over p and this is the x of S, and plus this term so this has to be 0. What can I do here? I can I'm just going to isolate x, and I can and if I do that, these e powers will drop out, So I get 1 minus 1 over p divided by 1 divided by p squared. So I just multiply both sides by p squared, the numerator denominator, by p squared. So I get p squared minus p divided by 1. And this is supposed to have a maximum. That makes sense. What is the maximum of this, or the extreme? We have to figure out that it's a maximum. That happens when if I write x as function of p, so basically x prime of the s coordinate of x coordinate of point S, that derivative has to be 0. And what do I get? I get 2p minus 1 is 0. So it has a extreme when p is 1/2. But since they already state that it's a maximum, then I have here my answer. Now I need to find the value of xs there. So I get xs max, substitute this in, I get 1/2 squared minus 1/2. That is negative. How come? Let's just double check everything here. This is correct. So the slope is correct. Did I make a mistake solving this? This is the function f at p. The slope x is p, or b is this. That is also correct. I have to set it 0. Minus sign. I moved xs, if I'll either xs to the left or this to the left, I get a minus sign, which I forgot. So minus here, a minus here. It didn't impact the calculation of finding out when this is 0. It's still at p equals 1/2. But then this becomes minus, sorry for the mess and lack of space, but this is what it is. It's then 1/4. Question 15. We have a line K through the origin with a angle alpha. There's a point M on the x-axis, which is the center of a circle with radius 1. And that circle has a tangent K through A. And then they say the coordinates xa, ya can be expressed in alpha. Calculate the value for alpha for which xa is 1/2. Okay. Well, I guess you can construct a line perpendicular to line K through A and M, and also that the distance from A to M is 1. Do this all algebraically. But let's see if it's possible to do this with some basic geometry. Oops. How do I get my pen? Here. So we want to know ya, and we already know this is 1/2. We want to express y of a in alpha. Well, let's look at this angle here. Let's hold that theta. The sine of that, the cosine of that angle, alpha, theta here, is actually the y coordinate of A. And see if we, and theta and alpha are actually related. You can see the two sides for this angle actually are perpendicular to the two sides of alpha. So actually theta is alpha. So we can say consider no, let's just say that from the drawing that cosine of alpha is ya divided by 1 is ya. But we also know so actually we did what is said here. You can express ya in alpha, but they want to know what alpha is. So we also know this has to be on this line. So since ya has to be, this is the line K has a slope, the tangent of alpha. That's the definition of the slope. So that means that ya is just the tangent of alpha, well, times xa, which is 1/2 tangent alpha. So now we have two equations for YA and alpha. So let's just substitute this here. So we get the equation cosine alpha is 1/2 of tangent of alpha. Okay, it's actually not that difficult. That means the cosine of alpha divided by the tangent of alpha equals 1/2. And that means cosine of alpha divided by the sine, and again divided by the cosine of alpha has to be equal to 1/2. So cosine squared alpha divided by sine alpha is 1/2. Okay, well, let's express the cosine squared here in 1 minus sine squared. So by doing that, we basically have one unknown, namely the sine of alpha. And let's define a u which is sine alpha. So you get 1 minus u squared divided by u is 1/2. And so you get 1 minus u squared is 1/2 u. And let's just bring these to the right, so we get a plus sign in front of the u squared. It doesn't matter, but then you get u squared plus 1/2 u minus 1 equals 0. Don't think it's easy to factorize. Maybe you can split the square. Write it as u minus u plus 1/4 squared. Need to, since I write it in this way, I need to subtract actually 1/16 minus 1. So actually this is not super pretty. I get u plus 1/4 squared equals 17/16, or u is 1/4 plus or minus the square root 17 divided by 16. Well, not super pretty, but we actually don't need to do it analytically. As a matter of fact, let's just put this equation here in the calculator, in the graphics calculator, and solve for it. I mean, I can check what minus plus the plus 17 over 16. Oh my god. 15 over 16 to the power 1.5. 0.78. Well, okay, why not? Let's just keep 3 decimals. And then the minus sign here. It's minus 1. The other one is minus 128. But that's, since u is the sine of alpha, that is actually not possible. That won't happen in this system. So I just ignore that. So I get u is this. That means then that alpha is the inverse sine of that 0.78. I can do it in Wolfram, but that's always a radian. So let me just quickly do it here in the Windows calculator. This is 51. Keep 3 significant figures, so I get this. But we had to put it in whole degree, so it's 51. Yeah, again, I don't think there's a lot of value in splitting the square here. That will be necessary if they want to have like an exact number. What we could have done is just plug in this equation, and I should get the same answer. If not, some mistake was made. So I set this equal to 0. Yeah, these are the numbers I got. So yeah, I would just use this. And I think that is what was being asked here. We have to get alpha. Okay. Final question 16. For every angle alpha with alpha between 0 and 90 degrees, the line K is a tangent of the circle in point A, and also the circle intersects with the x-axis to the right of the center in point B, and there's a point C above the x-axis such that MC here will bisect this angle AMB. So C you can kind of construct by doing that bisection and crossing it with the circle. And the M, position of M, and therefore also the area of this triangle MCB, MBC, depends on the angle alpha. Yeah, that makes sense. Because, well, what happens if alpha goes to 0? The only way that can happen, since this radius is 1, is that this circle moves away, moves to the right. And then what can happen is that A approaches the top of the circle. And then I guess, well, we see what happens with point C then. Okay, well, what is the area? Let's call that A, not to confuse with this point A. The area, so let's just then give a label, triangle, or just T. What's that? It's half the base times the altitude. So 1/2 mb times the altitude, which is the y of C. And y is greater than 0 is given here. And mb is 1, so I just get yc divided by 2. Okay, so I have to find yc as a function of alpha and then show that it has a limit. So let's try to do that. Well, this is a unit circle. So if I know this angle here, let's call that theta. That's the kind of half the angle that's being bisected here. Then yc is just the sine of theta. That is actually the definition of a sine in cosine. The cosine would be the x-coordinate, but that means that yc is the sine of theta. And, well, what is theta? We know this triangle OAM is a right triangle. So this angle here is 90 minus alpha. And if I know this triangle, I can actually know theta, right? Theta is also here. So, because these should add up to 180. This is a right, so I call it a straight angle. So, what is theta? Well, 90 minus alpha plus 2 times theta is 180, or 2 theta 180 minus 90 minus alpha is 90 plus alpha. Okay, so theta is 45 plus 1/2 alpha. Okay, so now I think we have everything we need. We were missing yc. We can express yc in theta and theta in alpha. And you can actually see what's happening. This theta here has like a lower limit of 45. So AT is then 1/2 times the sine of 45 plus 1/2 alpha, and that means it has a lower limit of 1/2 sine 45 degrees, and that's our answer. And this, by the way, is 1/2 square root of 2, so it's 1/4 square root of 2, which completes this answer.